Hello and welcome back to Calculus. First, as always, I want to thank all the nice people that support this channel by liking and subscribing. In today's part 29, I would like to speak more about kinematics. Now, going way back to part 13, we took a look at what kinematics is and how it works with derivatives. So let's refresh our memory. Firstly, kinematics is the study of how objects move, and there are three primary components that are vital. We always have to consider a starting point. Of course, we also need to know the direction that the object is moving towards. And lastly, we also need to know the distance. So this, in short, is basically what kinematics is about. Now, combining it with derivatives, we can actually figure out velocity when we have one of the three things. We can either find velocity if the displacement function s of t is given. Here, please note, t just means time, much like the x in a y function. And we also know the correlation between displacement and velocity is the following. The derivative of the displacement function is going to be the velocity function. Another correlated function is the acceleration function. Please recall that if you do the derivative of your velocity, what you're going to get is the acceleration function. Please recall that we had this formula right here that describes the correlation between these three functions. Please also note that at that point in part 13, we only knew how to do derivative, meaning we could only do all of these things in one direction. However, now that we have fully learned integration too, if we are given the velocity function, we can do the integral of it and find the displacement. Vice versa, we can also be given the acceleration function, do the integral of it, and get the velocity. So now everything is clicking together. However, this time in part 29 in Kinematics 2.0, I would like to look at it from an integration perspective. To be precise, we will use integration to find two things. One, we can use integration to find the displacement of a particle within a time frame, meaning, for example, from time 1 to time 2, usually just abbreviated as T1 to T2. Please recall, displacement is not the same as distance. I used this example before. Suppose you are running on a standard Olympic track, which is usually 400 meters. If you start the race at the start line and then run a circle and finish at that same point, your displacement is technically zero, because displacement means how far away you are from your initial position. And then the second thing we're going to try to find is distance traveled by a particle within a time frame. So let's first get to displacement. Displacement, usually denoted with s, can now be found with an integral from one time to another time. So basically within a time frame. The function we're going to be taking the integral of is none other than the velocity function. I could argue that in kinematics, velocity function is probably the most important out of all, especially since velocity can denote both speed and direction at the same time. So the formula is as simple as this. The integral of the velocity function from one time to another is going to tell you the displacement. As a mini example, let's say we're given the velocity function t minus t cubed, and we're asked to calculate the displacement within the first 2 seconds. Well, that means your displacement s is going to be equal to the integral from 0 to 2. of the function t minus t cubed. And the answer you should get is a negative one, specifically negative 2. Usually in kinematics, a negative displacement value can mean two things. Either you weren't moving forward, rather moving backwards, that's why your displacement is negative, or another thing it can mean is that you are moving towards the left-hand side and not the right-hand side. Displacement is positive on the right and negative to the left. And now let's get to the distance. I can tell you immediately that the formula is the same with one additional thing: the absolute value signs of velocity. Here is the difference. For displacement, if you're moving forwards 10 meters and then backwards 10 meters, displacement is 0. So technically, distances cancel each other out. You can have positive and negative ones. But for distance, if you travel 10 meters forward and 10 meters backward, the distance is 20 meters. That means positive ones and negative values have to be turned to positive in order to calculate the distance, and thus the absolute value signs. So that means with that same mini example, same velocity function, let's say this time we're asked to find the distance traveled in the first 2 seconds. So now that same integral applies. All we have to do is apply the absolute value signs to the function. And using technology or doing this by hand, however you like, the answer you should get is 5/2. Sadly, in this video, I will not go through a precise, difficult example to show you the mechanisms. However, if you do want to see one solved full example with explanations, please check out the PDF version of this lesson from the link in the description. And also, the other link is to a folder with all the PDF versions of our 29 lessons so far. So that's good enough for today. Starting from the next video, we will look at another major application of calculus in real life, more specifically ordinary differential equations. Sounds like a mouthful, and I will tell you more next time. So I hope to see you there and have a nice day. Bye!